Okay, good morning everyone. Welcome again to APNIC eLearning web class. Today's topic is about DNS concepts. Now this is part of a series. After this we have reverse DNS and then some DNS security. But for this particular session, our focus is on the how DNS works, what is the purpose of DNS, and how you can start implementing DNS. All right. So before we do that, just a few housekeeping things. Today is the 27th of May in 2015. It's 11 in the morning from Brisbane in Australia, where I'm broadcasting this class. And briefly, I'd like to also introduce myself. My name is Cheryl Hermoso. I work for the training team as part of APNIC. And within the training team, we conduct face-to-face workshops, online e-learning sessions like this. We attend blog events, do tutorials and all that things that covers many topics in the internet sphere. So we do network security, IPv6, DNS and DNSSEC, internet resource management, routing, and BGP. Now this session will run for 1 hour, and at the end of the class, I will be asking you to fill in a survey. The link for the survey I will be posting in the chat as we are about to end. So please take some time to do that because it's very important for us to know whether you gain something from this and whether there are things that we can do to improve this class. All right, now for an overview of what we're going to cover for the next 1 hour. So basically we will go into the depths of understanding what DNS is and some terminologies that are very much related to it. So we'll try to understand the differences between domains, namespaces, zones, and delegations. And of course, we'll look at the features of DNS, what makes it a very important network infrastructure. So basically, it's an application that is critical to the functioning of the internet. And we also look at how it functions, how to query the DNS tree, what are the different components that are used to serve your DNS records, what are resource records, what are the different types of resource records. We'll look at how to implement them, and towards the end, just a few slides on what aspects you should look at when it comes to performance of your DNS servers. So let's begin with an understanding of DNS. I think all of us have some basic knowledge of what it is, right? Basically, DNS is domain name system. And it's basically a lookup mechanism. It is used for translating one object into another object. More specifically, most of us will think of that as mapping names, which is your domains, when you check your websites, when you send an email. So those are basically the names. And then we use that to map into numbers, IP addresses. It can be IPv4, it can be IPv6. But it's not always names into numbers. It can also be the other way around. If you have an IP address, you wanted to find out the corresponding domain name for that, you should be able to do that as well. And there are also many different types of objects. So generally here we're talking at them as objects, but it can be different types. We will look at them more closely when we discuss about resource records. Now, a few characteristics of DNS. As we know, DNS is a critical infrastructure. It's a critical piece of the internet. Now, it's important that we make it available all the time because we do queries every time to those DNS servers. So an important characteristic of DNS is this thing. It's a globally distributed, loosely coherent, scalable, reliable, and dynamic database. Now, if we look at the history of how this came about, it's because we wanted an easier way for us to remember different hosts, right? So it started out with a host file. So we have a single file that maps a name that we assign to a machine. So you say, they use very big machine at that time, and then map that to the IP address that corresponds to it. Now, as the internet grows, we need an easier way, perhaps, or a more reliable way to do those mappings. Now, we cannot have just a single file or a single database that will contain all of those mapping. obviously, as it becomes more global, it tended to become now more globally distributed. But they should be part of a hierarchy, right? They should be part of a system. There has to be a way for you to get to another system, so another say set of mappings by going into the DNS hierarchy tree. So we will look into them more closely as we go on. Now, more specifically, there are three different components that are important to understand with DNS. One is a namespace. So let's try to identify the difference between a namespace and typical domain. Now, another one is the server. If you have a namespace, you need a server that will make this namespace available. Those servers will answer queries from other machines who are now asking for those mappings. Now you should have this machine as your lookup mechanism. The last one here is your resolver, which is your client. Most machines, most operating systems are also resolvers. So when you say resolver, it's the machine that sends the query to the server, to the name server, when they want to query for a particular namespace. So that's how all these three components are interrelated to each other. Now let's try to understand how DNS work first, okay, before we go into these components. Now, obviously, you have a machine, you want to connect to, say, a server. Maybe it's a web server. In this example, I have my computer, I want to connect to www.apnic.net, so it's a web server. Now, how do I go about that? Obviously, in a packet level, when I want to connect to something, I'll be sending packets, and those packets need IP address, a source address, which is my IP address, and a destination address, which in this case is the IP address of this web server. Okay, just trying to use my pointer here, this web server. Okay, so how does it go about? I need a third-party machine, a DNS server, which resides maybe somewhere locally, maybe it's somewhere on the internet, but basically I will ask this DNS server for the mapping. What is the IP address, or in this case it's the A record, what is the A record for www.apnic.net? So I'm going to ask that from the DNS server. How do I know where to go? Obviously, I have in my settings, either it's manually configured, either I got that from, say, a DHCP server. I have an IP address that corresponds to my recursive server, which is this DNS server here. Okay, so I usually put them a primary, secondary name server, and that points me to this DNS server. That's where I go first to ask my question. Now, this recursive server will do a few things, and then once it has the answer, it will reply back to me with a corresponding either IPv4 or IPv6 address, and from that point on forward, my conversation goes directly to the web server using the IP address that I have obtained from the DNS server. That's how it works in a general sense. Now, these are the DNS features that I was talking to you about. Now, we don't just go to a single DNS server and get the answers outright. Okay, we have mentioned that DNS is a globally distributed system. You have different machines, different servers that are able to answer, that are authoritative to answer specific queries only for them. Okay, so that's how we share the load. You don't have a single point of failure. You have many different DNS servers located all around the globe, administered by different people, and through that we are able to answer queries faster, more reliable, and all that. Now, as said, there should be a way to link all of those DNS servers, and so although they are globally distributed, they are part of a system, and this is how you do it. They have loose coherency. If you have, say, if you're the owner of .com, that domain, and then you have given the administration of subdomain.com or myzone.com to someone else, there has to be a way to link the parent to the zone. Okay, so although it's globally distributed, the information that you will get will always be the same because you are able to go to the authoritative server, the machine that can give you the answer. And that is done by having links between the DNS server that points you to the machine that is authoritative to give your answer. Okay? Your DNS should also be scalable. Basically, you can definitely add DNS servers as you want without affecting the entire DNS system. It's globally distributed, so that makes it easier. It's very easy to scale the infrastructure because many administrators are in charge of different segments, of different nodes of your DNS infrastructure. Because DNS is a critical infrastructure, it has to be reliable. You are encouraged to have at least two name servers that can answer queries so that if one is down, you have another that can still perform the function. It is also well recommended that you put them in separate locations, as much as possible globally distributed, one perhaps in the Asian region and another somewhere in the US or the Europe region, things like that. That's how you make your DNS reliable. Nowadays, that should be easy. With the cloud, you are able to deploy your infrastructure that is more reliable, that's more resistant. Now, another one is dynamicity, depending on the data, depending on your domain. There has to be a way to modify, to update the entries in your records, either manually or dynamically. If you do it manually, if you have, say, domains that doesn't change very often, then you can do it in batches. You can do it one at a time, but it doesn't affect your DNS performance. But if you say your data changes every few hours or every few days, then you also want your DNS server to be available, right? To be up for all the customers or for all the clients all the time. Therefore, you might want to explore dynamic DNS, where you can make updates outright into your DNS server without stopping and restarting the service itself. That's what we mean here by dynamicity. So those are the features, and you can see from this DNS hierarchy tree how it can utilize that. This is the DNS hierarchy tree. You have a DNS server. It doesn't know all of the answer to your question. That's because it's globally distributed, right? It starts with the root, which is the very top of your DNS hierarchy tree. It branches out to different nodes. These ones are what we call as a top level domains or TLDs. .net, .org, .com, .arpa, which is for reverse. You have CCTLDs or country code top level domains. Examples are here, .au, .ph, and all that. You also have generic top level domains. These ones, net, org, com, and a few others, are examples of generic top level domains. Nowadays, we also have internationalized domain names. So rather than using the typical alphanumeric characters that we use for our domains, you can now use different characters, let's say Chinese character, or basically different types of characters can now be utilized. If you have one for your country, for your economy, then it will be good to explore that as well. So that's your top level domains. So again, from the root, it branches out to these top level domains. Now these top level domains are handled by different organizations. After that, for example, here you have .net. It also then branches out to smaller subdomains. So an example is APNIC.net along with others in that node. Now from APNIC.net, notice here we also branch out. We have who is, www, we have training. So these are all different nodes as well. So how do you write down a domain when, say, you are typing something on your browser, right? You normally put in, say, training.apnic.net or www.abc.net.au, something like that. So if you notice from the DNS hierarchy tree, that's actually what we call as a fully qualified domain name. If you traverse this DNS hierarchy tree, it's actually coming from the bottom going up. So if you write your domain, right, it's something like training.apnic.net. And then when you do this for, say, when you're configuring your DNS servers, don't forget the trailing dot at the end. That's what makes it a fully qualified domain name. You're basically traversing your DNS hierarchy tree from your node, from the specific node that you want to look at, which is perhaps www in this case, and then traversing that all the way to the root. So www.abc.net.au. Okay, so I hope you understand when we mean FQDN or fully qualified domain name, that is a very important concept in DNS, especially once you start configuring your resource records that are within your zone file. Okay, now here is a description of basically what a domain is, and also after this, what is a namespace. Now, first of all, when we talk about domain, we say .net domain, .com domain. What does that include exactly? Here, you can see it's an example, .net domain. Another one, .au domain. So from that example, you can say that when you talk about domains, it involves the node, the specific node that you are interested in, and everything, all the nodes, all the branches that falls under that domain. So .NET domain here, you can see includes everything all the way to 1 to about 3 layers down, can even be more. Essentially, everything that is under that node is part of .NET domain. Okay? Now, to differentiate that, another example here, you see APNIC.net. APNIC.net domain, okay, also involves everything under APNIC.net. But obviously, it doesn't involve .net. Okay, so it's more of a subset of the entire net domain. So it's very easy to understand that. But why am I talking about this? It's because in DNS, we said that it's globally distributed. So delegation is an important concept. What exactly is delegation? See here, when you say delegation, we have administrators of different nodes. These different nodes can create smaller nodes or subdomains and then assign that to someone else. Okay, so an administrator of a group for, say, apnic.net can be different from the administrator of .net. So in this case, you have .net, that is your parent zone, and then you also have apnic.net. Now, .net administrators can handle apnic.net, that's not a problem, but they can also delegate that responsibility to someone else. Maybe administrators, I would say from APNIC, would want to handle or manage that node itself. Then apnic.net is now delegated to those administrators. That's what we mean by delegation in this case. You have a domain, you delegate the responsibility of the subdomain going to someone else. Now, another important concept, we'll look more into delegation in a little bit, but another important concept that is related to this is linking of the parent zones into the child zones. Okay, this is how we make it still loosely coherent. Although they are independent of each other, although you have different administrators working on different nodes, there is a way to link one node to the other. So this is how it's done. Your parent node delegates the subdomain to someone else, but the parent retains a link, okay, going to that subdomain. Okay, the parent essentially remembers to whom it delegated the subdomain to. All right. Now, why is that important? Again, it's because we want to define what is zone. We already know what's a domain, but what is a zone? A zone is kind of a domain, but it's more administrative space. Okay, a domain involves everything that falls under that node. A zone is different. Once a subdomain has already been delegated to someone of my administrative space. So when I have delegated, say, a child zone, therefore, that will not be part of my authority anymore. That will now be the child's authority. Okay? So authority is delegated from the parent to the child. And once I've done that, it is no longer part of my administrative space. So let's look at this example to understand that more clearly. So this is the same one that we've seen earlier. You have your .NET domain. Okay, you already know what is .NET. What is .NET domain here? It involves everything from .NET going down. But what about zone? Here, I have another one, APNIC.NET domain. Now, when you talk about zone, if I have now delegated APNIC.NET to someone else, then my zone will only involve .NET. And whatever subdomains is still within my responsibility. Okay, so APNIC.NET zone involves this. Okay, if I have delegated, let's say, I've delegated training.apnic.net. Therefore, APNIC.NET zone does not involve training.apnic.net anymore. So this will be part of training.apnic.net zone. So you see the difference. You have the .NET domain which involves everything, but with the zone, it's kind of smaller because the responsibility is now transferred. In this case, APNIC.NET has now responsibility that's taken from the child zone from .NET. Training.apnic.net also has a different set of administrators outside of APNIC.net zone. Okay, so when you do delegation, okay, the child zone that has been delegated no longer becomes part of your zone or your administrative space. Okay, so I hope that's clear with everyone. So that's the very first component that's essential to understand with DNS. So if, say, you go to a hosting provider, you wanted to get a particular domain, myzone.com. Okay, once you get that, they will now delegate that subdomain to you. You either provide 2 name servers to them if you want to manage that by yourself. But if you don't want to, then there's no delegation. They will handle all of that. So every time you make changes, every time you want to add records, then you have to go to your parent zone. But if you want to manage it by yourselves, then you'll need to do delegation. You will then have to maintain your own name servers. So that's the second component here, name servers. Name servers are your actual machines. You have a DNS software installed into it. You have your records added into your zone files, and they can answer DNS questions. Now, there are different types of name servers. Particularly, we can categorize them into 2. One is authoritative, another one is caching or recursive server. So what's an authoritative server? First of all, once a domain has been delegated to you, you're responsible for that domain, right? So that responsibility means that you are now authoritative to answer any queries for that particular zone. So in your name servers, you have, say, let's say this 3. This 3 can answer queries for, say, host1.myzone.com, okay, or host2.myzone.com. You have entries for those records. So with authoritative server, basically you are the authorized server to give answers. Now there are 2 types here under authoritative server, and that now depends on their function. Okay, they all are authoritative for the zone. They all can answer for that zone, but you will have one that's acting as primary, and all the others are secondary name servers. What do we mean by that? Now, all of 3 have the same information in it, right? They should be able to answer the same questions. If I want to find out the IP address for host1.myzone.com, I can go to any of these authoritative servers and I should get the same answer, right? Now, do I have to, let's say, update all of these servers every time I add an entry or make changes and delete entries? The answer is you only need to do it once. You have to update only the server. So basically, I said you should have redundancy, right? So you have to maintain at least 2 name servers. By default, a typical setup will have 1 primary name server and 2 secondaries. The primary server is where you make all your updates, add entries, add resource records, and then this will then be propagated to the secondary name servers. Okay, you only need to update 1 name server, and every other say record will also be updated in the secondary name servers. Okay, so you have to nominate one, and then the secondaries will pull the new information from the primaries. The next one here is your recursive server. Remember during, I think that was slide number 2 or number 3, where we showed the basic function of a DNS. So you see there, you have a client goes to the DNS server. Now that's the function of that DNS server. It's acting as a recursive server. When you say recursive in this case, you have a client. The client is your resolver. The resolver does not have any recursive function. When you say recursive function, it will go to the DNS hierarchy tree until it finds an authoritative server to give answer to it. Okay, so it basically is configured to go to the root. So if you remember the DNS hierarchy tree, it will go to the root, and then the root will give him an answer. Now the root has delegated the domain already, right? So he's not authoritative for that zone. He will give referrals to where to go next to get the answer to the question. So it does the recursive function, goes to the root, goes to the TLD until it finds the authoritative server that can give him the answer. Okay, that's the function of a recursive server. Now most recursive servers are also caching name servers. When you say caching here, the answers to the questions or to the queries will now be stored in my recursive server for a particular time. So let's say I queried for APNIC.net. Another person in the company queried for the same question, right? They also want to find out the IP address for APNIC.net. So you can do that. If I'm the recursive server, I will do the query once, store it in my cache. When client number 2 asks me for the same question, it is in my cache. I don't have to do the recursive query again just to give that answer. So the answer will be faster than the previous one. So that's the purpose of caching. Now it will be in the cache for a certain amount of time, which is what you call as the time to live or TTL. Once the TTL expires, I will have to do the query again, doing the same recursive function that I have done before. Okay, so that's a function of your recursive servers. Now most name servers have mixture of functions. If you're authoritative for say a zone, then you can also act as recursive for all other zones. That's a typical enterprise setup. So most ISPs as well are acting as, say, they provide some services for their customers, for their subscribers. So they can do that. They're acting as a recursive server. But for the zone, let's say my ISP.net, then I'm authoritative for that zone. So that's what we mean here by mixture of functions. Any questions so far? So going through that, I've mentioned about the recursive function. This is how it works. I have a client. My client wants to find out the IP of example.edu.au. So I'll go to the recursive server. Okay, this is my local DNS. That's my recursive server. This recursive server goes all the way to the root to ask that question. And then obviously the root doesn't know. But it has delegated the subdomain, which is in this case .au. So what he's going to do is reply back saying that I don't know the answer to your question, but you can ask .au. Here is the IP address of .au. Remember when we said that the parent must remember or must know the to whom it delegated a subdomain to. This is what we mean by that. The root is now able to give the IP address of .au. Now I will go to .au, ask the same question, what is the IP of example.edu.au? .au obviously doesn't know in this case because he has already delegated .edu.au. So again, he will reply back saying that I don't know the answer to your question, but please ask .edu.au. Here is the IP address of .edu.au. So I'll basically go through that process until I get to a point where I find a an authoritative server. So that's this one, example.edu.au. Now the response is no longer a referral to another name server. I will now get an answer, okay? And the answer is m.n.o.p there. That's the IP address of the web server. So I will now reply back to the client with that IP address with that answer, and the client can now contact the web server, for example.edu.au. So that's how it works. That's why you need to maintain proper delegation. That's why you need to maintain contact with the DNS hierarchy tree because of this process. Because if it's broken somewhere, let's just say after .edu.au, I now refer you to example.edu.au, but the IP address that's in my records are not correct, then there's no way for me to get the answer to my question, right? So that's what we call as lane delegation. So make sure that if you, let's say, for example, in the future, you change the IP address of your name servers or you change the domains, etc., make sure that you update your parent zones about that. Any questions? So, all right, your name servers can answer queries. So what do I ask from the name servers? I will ask for entries, right? I will ask for records. So these are the resource records that are now stored in my name server, either in a text file or in a database. The components of a resource record, so if you look into what we call as a zone file contains all the resource records. All the resource records follow the same syntax. They should have a label, they should have a time to live or the TTL, they should say whether it's type IN or CH, that's a class, and then what is the RR type? Am I an A record, quad A record, MX, PTO records, and all that. And then the last one, which is everything that follows the type part of your resource record, that is your R data. You'll see some examples here. These are the common resource record types. You have A record, which is essentially your IPv4 address. It maps a domain name to an IP address. This is an example. Now some of the fields here have been left out, but essentially it will take the values from the one on top, or if you define a default value. In this case, we don't specify the TTL anymore because we have either specified that at top or we will use a default value. Right? So you see here www.apnic.net, which is your label, that's your label, and then IN is your type, A here is your RR type, and then the R data is your IP address. So depending on the resource record type, obviously the contents of your R data will be very different. If you talk about IPv6 address, you will now use quad A record, okay, as opposed to A record previously. With quad A record, it will look like this. You have the domain, quad A, and then the IPv6 address. Other resource record types that are important are NS records, which provides you with the name servers. There are two main functions of NS records here. One is to tell everyone that you are the authoritative, that these name servers are the authoritative for that zone. So in your zone file, you'll essentially have a SOA record at the top, followed by the NS record. That NS record will be the name servers that are authoritative for your zone. Now, if you're doing delegations, you will also use the NS record to now point to the name servers of the child zones. Okay, so those are two main things where you use NS records. You also have PTR records. So before, most of the ones that we had previously are mapping names to numbers. But if you want the opposite, you want to map an IP address to a domain name, then we will use a PTR record. It doesn't matter whether it's V4 or V6, everything will be using PTR record if it's IP to a domain name. Next one here is CNAME. Let's say, for example, that in a same host or same server, you have many services for that, or you just want a different name for that zone, maybe let's say for your www site, you can also go to web.apnic.net and it will lead you to the same service. Then you can use a CNAME record. Last one here is your MX record or your mail exchange. Now, if I want to send you an email, so send me an email to cheryl@apnic.net, right? Now, how do I deliver that mail? I should know the mail server. Okay, where is the mail server for this? In this case, that's mail01 and mail02.apnic.net. So here we're defining that for this domain, apnic.net, these two mail servers are the ones that can receive that mail. So I will also find out the IP address of mail01, mail02, and that's how I get to it. That one, by the way, will be using a record. Now this MX record is a bit different than the others because as part of its R data, you have some number. Okay, this number indicates priority. So you provide two mail servers at mail01 and mail02. When you have a lower number in the priority, that means it has higher priority. So in this case, it will try to reach mail01 before mail02. Okay, so that's your MX record. Now I mentioned SOA record, but I did not put that in the previous slide. This is how it looks like. So when you create your zone file, so you have myzone.com, right? So your myzone.com, you're authoritative for that. You're now creating a zone file for that domain. So when you open up your, say you do it on a text file, you do it manually. Again, you can also do it via database and all that. But if you want to do it, let's say manually, you open up your zone file, okay? And then at the very top, you specify a SOA record. Now, SOA record is important. It usually goes on top because it defines a few things. It defines your domain, it defines who will be the administrator, what will be the email address of the administrator and all that. But more importantly, it gives you some timing parameters. Now on top here you have a serial number. That's very important because serial number is used when you make changes, add anything, add entries, remove entries. So anything that you do in a zone file, okay, you indicate that you made changes by updating the serial number. Normally, it's any number that is incrementing, but typically, common practice is we use the date today. So if the day is the 27th of May, you do 2015 05 27, and then follow that with two extra numbers, 01, 02, and all that. So it's basically incrementing. So it's 10 digits, so you're the date plus two numbers. So that number will be incrementing every time you make changes. It's also a good way of, say, have a form of documentation. You know when you made changes into something by looking at the serial number. Now, what other purpose does the serial number have? Now, we said that for an authoritative server, you have a primary, you have secondaries. Now, the secondaries will pull the updated information from the primaries. Now, how does that happen? How do I know that there have been changes? One is by looking at the serial number. So every so often, the secondary name servers will come to the primary and check whether the serial number is still the same or whether it has been implemented. If it has changed, then I can make sure that obviously there have been changes. So I will now get that new zone file from the primary server. That's what we use the serial number for. Now, how often do I go back to the primary? That is identified by the refresh time. So if you say every 4 hours, I will go to the primary to check whether there have been changes in the zone file and then pull the updated information. Now, if the primary name server doesn't reply, I will try that again. I will try that using the retry period. So let's say my refresh time is every 4 hours. My retry time is every, say, half an hour. So after 30 minutes, I'll go back to the primary, check that again. If it doesn't reply, after 30 minutes, I'll go back again and ask for the same question. Now, I will continue doing that until the expired time. So let's say my expired time is 30 days. After 30 days, my secondary will no longer try to reach the primary, and it will also stop serving answers or answering questions for that particular domain. That's how it works. So these primary parameters are very important. They are essential. You put values in there that are appropriate for your zone. If you tend to make changes very often, then maybe put at smaller values. But if you change that every month or every year or so it doesn't change very often, then you can put up higher numbers for these timing parameters. Okay, so that's your SOA record. These are the recommended timing values from RFC 1912. Refresh time is usually set for 1 day. Retry time about 2 hours. Expire time is 30 days. Minimum TDL is about 4 days. So again, it depends on the way that you utilize your server. Okay, depends on these factors. How often do you make changes? How soon do you want to propagate the changes? Okay, because there will always be delay. Typically, when you change something, okay, most name server administrators will say wait for 1 day, okay, just to make sure that it has actually already propagated to all your name servers. But if you want it to propagate faster, then you will make changes to the timing values even before you make changes into the resource records. Okay, so that's basically some of the factors that will influence what timing parameters you're going to use. Now this is an example of your zone file. As I've said, at the very top you will have your SOA record, then followed by your ENS records, at least 2 name servers every time, and then followed by all of your A records, C name records, MX records, and all that. Okay? If you notice, I have there the labeling for each. The syntax should follow the and use all the components that we have mentioned. However, you can choose to not include them. Let's say, for example, here, this line here, you have IN, you have A. If you don't put any value here, it will copy the one that is coming from top. Okay, the one from the top, which is who is the APNIC in this case, will be inherited to www.apnic.net. Okay, any questions? All right, so we're just about ending this discussion. Basically, we have identified how you can start maybe creating or implementing DNS. You need a domain, okay? You need a namespace. You have to identify what will be your administrative space. You need name servers. You should have at least 2. You should have a primary name server, 1 or more secondary name servers. You make updates to your primary name servers and that will be propagated. We've talked about the zone file, which contains all your resource records. So you make updates to your zone file, add records into it. If you have new machines that are coming in, you add new records to your zone file. You update the serial number so that it can then be propagated to your secondaries. You update the values of your, say, SOA record for the timing parameters if you want that to propagate faster. Now, if you have say you are delegating a subdomain, you can also do that. But then it will no longer be part of your administrative zone because you have delegated that. You must have a way to still reach the child zone from the parent zone for the proper query to be successful. These queries are done by a recursive server. It does the query from the top and it goes down to until it reaches an authoritative name server. Now I saw someone raising his hand. Now if I tick this, the microphone will be transferred to you. So can you please type in your question using the chat? I'll wait for that. But while he's typing his question, I'll also discuss a few things about the performance of DNS. Now here, we have already said that you can have your own domains, but obviously different domains will have different, different characteristics. One is how busy will it be? Or how popular is that domain? Do you receive many queries for that domain? Is it a big domain that you have 100 entries or 1,000 entries or maybe even more? And for each of those, how big will be the zone file? Now from that zone file, obviously it will be transferred to the secondary. Now how many secondaries do you have? For each of those secondaries, how long does it take for the data to be transferred? So those are the things that you have to remember. Those are the things that you have to think of when you are implementing DNS. In a DNS server, you can even host many different zones. So maybe you have 100 zones. If you refer to .com, okay, .com have thousands and thousands of subdomains, right? Some of them are hosted to their name servers, but some of them are delegated, okay? So you have to think of these things. Now, once you have identified those parameters, you will now look at the requirements for your hardware, okay? What will be the hardware that can implement this one for me? Now, if you have one zone, and then you only get maybe 1,000 queries per second or so, then perhaps you don't need much hardware requirements. You don't need much processing power or CPU because DNS is one of those services that doesn't take up much space or much CPU cycles, but it can easily scale. If you have, say, if you're hosting 100 zones and each of those zones are big, then it will have an impact on your performance. Now, one question there is, what's the purpose of the mailbox domain in the SOA? That's basically the email address of the zone administrator. If you want to reach them, then that's it. You're basically just providing information about the domain itself. Who's the administrator? Who's the host master? So if there's an issue with this domain, I can easily contact that person. And you can find that using the SOA record. That's basically the purpose of that. I hope that answers your question, Adrian. Any other questions from the class? So basically with the performance, as I've said, it will depend. Some name servers can easily act as a recursive and authoritative name server because for the authoritative part, they don't really, use up as much resources. Maybe you have more recursive queries than authoritative queries. But if you're authoritative for a large number of zones and each of them gets like high traffic, high number of queries, then it is best to separate your authoritative name servers from its recursive function. Okay, so that's something that you need to look at. When you do zone transfers, how large are your zone file? How many entries have you got in each of the zone file? Where are your DNS servers located? You want it to be globally distributed as much as possible, right? So you have some form of redundancy, and if you have some issues with one side, then it's still up in another side. So where are they located? If you're also doing zone transfers between servers that are geographically separate, then how long does it take for that to transfer? Now, if we talk about some of the biggest DNS servers, if you say turn it off or shut it down, shut the service down, and then restart it again, it will start loading all of those zones. Now, if you have, let's say, less than 10 zones, it will load up quickly. But you have 1,000 zones, you have to take into consideration the time that it takes to boot it up again, to start it, and start serving queries. Okay, so things that you have to understand. Are your servers multi-home? How many interfaces are enabled for listening? Who are your customers? Who are your clients? Now, very big problem with DNS these days is that most administrators just turn on DNS, make that available, but it's an open DNS. It's open for everybody, which is not good from a security perspective because anyone can use that, okay, as a, let's say when they're doing an attack. So for us to secure our servers more, we have to identify who will be our clients. For say enterprise setup, then it should only be available to the IP address of your enterprise network, not to everyone else. You should limit who can do queries from your name server. You should limit who can do zone transfers from your servers and all that. Now, if say DNS amplification is a huge thing these days, with DNS amplification, that's basically a DDoS attack where they use the DNS server, do a query as usual, but they're sending lots of queries for that name server, and then the responses, which are much bigger, goes to a target IP or target host. So in this one, how many queries are you expected to receive? Is that zone usually busy, or do you receive as much queries for that every time or not? So you need to make a proper gauge, maybe some observation on this. And if you think that it is now being used, say it's now being attacked, then make sure that you limit how many queries that you get. There are ways that you can do that depending on the DNS software that you use. Okay? Other things that might affect the performance of your DNS is, of course, if you're doing recursion and also if you're doing dynamic updates, because you make changes into your DNS or to your zone files every time when you do dynamic updates. Now we also have DNS notifications. Some of you can set up your name servers in such a way that if you make changes into your primary, it will automatically notify all the secondary name servers. You don't have to wait for the time, say for the refresh time, to come to the primary server. You can notify it outright, and the name server can now go to the primary to get the updated zone file. But when you do DNS notifications for a lot of zones, for a lot of secondary name servers, then obviously it will also have an impact in the performance of your DNS servers. So those are the things that you have to consider when it comes to this. All right, so obviously there's a lot of things to note. It's very easy, I would say, and there's a lot of DNS software that are easy to implement. You just need to check, say, DNS bind. For doing recursion, you should check out Unbound or NSD for authoritative. There are other different DNS software that are available out there. But basically, these functions are mostly the same. Okay, you should be able to understand how DNS works in this sense. Are there any questions from the class? Okay, there's someone typing in, but like while he's doing that, I'm also going to share the link to the survey. Okay, so here's the link to the survey. So if you have no questions, please help us by looking at this survey link and filling it up, please. If you want a copy of the slides, usually it should link you there directly, but we have some issues with SurveyMonkey at the moment, so I'll put in the link here as well. Okay, so it's this one. There you go. All right, so hopefully it has been a very useful session for you guys. As I've said, this is just the beginning. If you want more, you can attend the next session, which is, well, not for this next session here, but we have another topic on reverse DNS. We have another topic on DNS security, which kind of involves DNSSEC. So that's the next thing for you to understand once you have a complete understanding of DNS. All right, so if there are no questions, I think we will end there. Thank you very much for your time and for your attention. We have other sessions for today, which are, I think, routing and resource management. So please feel free to join us. You can log in as guests or you can use your own accounts too. Okay, thank you very much, everyone. And